Our planet is under pressure. We all know that climate change, population growth, and an uncertain economic situation are severely stretching our natural resources. We worry about fuel, water, but what about the soil, the stuff at the heart of the world's food chain?
Hi, I'm John Quinton, Professor of Soil Science at Lancaster University. Protecting and enhancing our soils for future generations is essential. In this film, I'm going to be introducing the topic of soil security, and in particular, why we should be protecting the carbon that's stored in our soils. First, let's examine why we should treat this dirt like gold.
Our growing population all need food, and where does that come from? Soil. In fact, 90% of food relies on soil. No soil, no food.
The soil is ram full of biodiversity. There are literally millions of species of bacteria, fungi, invertebrates, and the odd vertebrate too. It's also a rich source of antibiotics and medicines, and the bacteria and fungi are important for cycling nitrogen and phosphorus, essential elements for plant growth.
We rely on soil to support our infrastructure, roads and railways, the homes we live in and where we work. All rely on soil as a foundation. Soil is also a key reservoir, storing more than 2/3 of all the planet's fresh water. It also filters that water before it reaches our waterways, removing many of the contaminants which would affect their ecology and human health.
But soil is also the largest terrestrial carbon store, storing more carbon than the trees and atmosphere combined. Globally, that's 3,000 billion tonnes of the stuff. In the UK alone, there are 15 tonnes of carbon for every man, woman and child. It's the role and cycling of carbon that we're going to focus on now. Carbon, as soil organic matter, is vital for many soil functions. It's what makes soils fertile. It holds on and supplies nutrients to crops like these. It improves the soil's available water holding capacity, supplying water to crops, but also preventing flooding.
Carbon also provides the energy and food for soil organisms like bacteria and fungi that produce the glue that sticks aggregates together. This makes soils that are more resistant to erosion and better at filtering water. These soils can reduce pollution and promote good water quality. Let's think about how the soil accumulates carbon. In simple terms, the carbon cycle has 3 components: a store, the soil, a flow in from plants and animals, that could be leaves, dead plants, roots and dung, and dead bodies. And then there's a flow out, mostly to the atmosphere in the form of carbon dioxide, but also into the water as either dissolved or particulate carbon. It's the balance between these 2 flows that controls the size of the store.
Of course, the flows are different in different environmental settings. In this lowland agricultural soil, tillage has broken up the clods, providing the microorganisms with better access to the organic matter, allowing them to decompose it. However, in contrasting wetter and colder conditions, this wonderful soil called peat can form. The colder temperatures reduce the rate of chemical and biological reactions, and the wet conditions slow the rate of decomposition. So, we have the largest terrestrial carbon store literally beneath our feet. Securing it for the future is going to require answers to some big questions.
What's the status of our soil carbon stocks? Where are they in decline and where are they growing? Changing the size of the store can take years and depends on the relative size of the flows in and out. But protecting that store is vital. Can we protect it using new combinations of crops or soil management practices which help to build carbon stocks? We also need to understand how these carbon stocks will change if changes in climate. If the climate warms, will all the peats begin to disappear as microorganisms oxidise more carbon, or will vegetation grow more actively, providing a greater flow of carbon into the soil than leaves it?
We've got a lot to learn. We're still trying to understand the role of soils in global biogeochemical cycles. There's much to be done, but what is sure is that we need healthy, secure soils for future generations.